Good morning, everybody. My name is Kane, and this is my participation video. And today I just want to talk about the basics of modal analysis and how that relates to homework 6. Just an overview of my PowerPoint. First, I want to talk about what is modal analysis, and then why do we do it, and then static analysis versus dynamic analysis, and then what our homework is asking, which is transient modal dynamic analysis, and then afterwards we'll relate that back to homework 6 and how that applies to the question. So first of all, what is modal analysis? Modal analysis is a technique to study the dynamic characteristics of a structure under vibrational excitation. And what we can determine from it are natural frequencies, mode shapes, and mode vectors. So why does it matter? Since we can determine natural frequencies of a structure, we can learn about how excitation of the same frequency affects our structure. So just to demonstrate, I want to show you guys this YouTube video of Tacoma Bridge. So you can see the bridge wobbling, and you can see some cracks are starting to form. So, so how this relates to why does it matter? High-speed winds resonated with the bridge's natural frequency, causing the bridge to wobble and eventually collapse. So the reason we do modal analysis is to find these frequencies and how they affect our structure. So there's two types of analysis, static analysis and dynamic analysis. And the first thing we want to ask is, do we want to analyze the long-term or short-term response? And I kind of broke it up into two categories here. Long-term, static analysis is what we want. The system and boundary conditions are time independent. We care more about the intensity of the load in static analysis. Excuse me. Uh, and if we want the short-term response, we want to be doing dynamic analysis. The system and boundary conditions are time dependent, and intensity of load is a function of time. Finally, the theme of our whole homework is transient modal dynamic analysis. And real quick, transient just means lasting for only a short period of time. So the definition of transient modal dynamic analysis is the analysis of a system's response based on time-dependent loading. And right underneath it, I just put a quick graph of the response of a system based on the amount of damping. Um, it says in the book that most engineering problems require a small amount of damping. So we could see critically damped, underdamped, and overdamped in this graph. Finally, how does this apply to homework 6? So if we take a look at problem 2, I'll just read it real quick. This example uses the same cargo crane that you analyzed in example cargo crane, section 6.4, but you have now been asked to investigate what happens when a load of 10 kilonewtons is dropped onto the lifting hook for 0.2 seconds. The connection points at A, B, and C can only withstand the maximum pull-out force of 100 kilonewtons. You have to decide whether or not any of these connections will break. So if I break that question down, first thing I see is I have to apply a load of 10 kilonewtons for 0.2 seconds. So that tells me that I'm going to be dealing with a dynamic system because I only care about my load, my short-term response on the crane, and my load is only lasting for 0.2 seconds. And so by breaking down all these definitions and terms, it really helped me to tie up this knowledge and understand what the questions were asking in this homework. And these are some references that I used for this presentation.